Okay, so I saw a few hands earlier. Some of you have actually already used Java 8, which is good. Has anyone actually tried the new DateTime API? A couple of hands? Okay, cool. Well, you can correct me where I'm wrong. So this is not an exhaustive talk. I've got 10 minutes, so I'm not going to go into how many CPU cycles it takes to do each calculation. So this is going to be a high-level overview to try and introduce everyone to the new DateTime API. So the first question is, why do we have a new DateTime API? For some of you it's already obvious, but the primary drivers behind JSR 3.10, which is the new DateTime API, is really about improving the quality and consistency of how you work with dates and times and time zones and all the sort of information that we currently already do inside our applications. So the new DateTime API is based on JodaTime, if anyone's already used that, except deep down under the hood, JodaTime still wasn't really quite designed in the beginning to do what it ended up doing. So JSR 3.10 was really an opportunity to go back and re-architect JodaTime to make it work faster and more efficiently. It's not to say there's any defects or anything wrong with JodaTime, but JSR 3.10 and building it into Java 8 was an opportunity to rewrite that. So that goes again towards the quality and consistency. Also worth noting that the new DateTime API is actually designed to replace the original methods and functionality. So at some point in time when they get to Java 25 or something, they will probably deprecate Java util date, Java util time, and time zone calendars and all that stuff, because it will all be replaced with the new methods. So, what are these new methods? So, there's a bunch of new types, and there's a couple of others that we'll add on as well, but I didn't put in this slide. But so the main ones that are available now that we can start using, we've got a local date, and that is just a date, unlike Java util date, which actually stores a time component as well. Local date is just a date, so it represents a particular day. We've got local time, and that just stores a time. That's the equivalent of Java util time. We've got local date time, and that's basically a combination of a date and a time, obviously. So local date time is the closest relative that we have to Java util date. We've then got a zoned date time, and the zoned date time starts to include time zones in it as well. And we've got an instant, which is sort of like a Java util date, but it actually goes all the way down to nanoseconds, and an instant is principally designed to be used for things like logging and stuff where you actually want a timestamp of an event or something that occurred. So, local date. So as I said, a local date object in Java 8 basically just contains a year, month and day. So you can instantiate it using a local date.now, or you can actually specify specific things. So in one of the constructors, it's got a passing a year, a month and a day, and that'll give you a local date object. So the new local date object now gives you a whole lot of methods. So there's an is-after, is-before method, and the toString method now returns a date in an ISO 8601, which is year, month, day format. There's also some other handy things. So you've got things like is a leap year, length of month, and you can also now manipulate these objects using some of these new methods, like there's a dot plus months or a dot minus days, plus years, minus years, and so on and so forth. So this starts to make working with dates a lot easier because it's easier to manipulate them and change values. And if you want to calculate the following month or the prior year and that sort of stuff, then it's a lot easier to work with these new methods. And these new methods are also consistent then across the times, local date times, and the time zone things and stuff. So it becomes more consistent. once you start using it, it becomes easier and easier to work with all of the other types as well. Other handy methods you got is with day of month, so that'll actually set it to the first day of the month, or you can reset and set the month of it, so you can say with month 10, or you can actually just use .with, and .with again is consistent across whether you're using a time or a localized date time, and so on and so forth. So you can actually specify with month April, which is the equivalent of doing with month, well not 10, but 4. So the final point is that you've also got these temporal adjusters. So these are really handy ways of being able to adjust or manipulate your DateTime object. So you can actually start to shift it to the first day of the month, last day of the month, the second Tuesday on the month, and those sorts of things. So again, it makes working with and calculating things a lot easier. And I'll show you a reference at the end of this slide deck from actually the Raspberry Pi MOOC course, and I think it was the first week in the MOOC course. They actually have getting a date and going off and doing a whole pile of calculations on it, and you end up going and calculating your modulus and then working out incrementing, by so many hours or so many minutes and stuff, and having to do all these mathematical formulas in order to work with and manipulate your times. It's a whole lot easier, easier to write and easier to read and understand using the new DateTime API. So local time is really similar to the date. So it's got a constructor of now, which is just the current system time, or you can actually construct a time using an hour minutes or hour minute seconds, and this goes down to hour minute seconds and nanoseconds. Similar to the date, it's got a .is after, so it's easy to compare two different times. It's got a toString, which again is in the ISO format, and you've got all these things to manipulate. So you can do a plus hours, minus minutes with nano. You can truncate it to seconds or truncate the minutes, which will just zero out the remainder of them.
Is there a convenience method for, say, just if you don't want it down to nanoseconds and you just want to do a time comparison, just at a seconds level or at a minute level?
So that'd be you use the truncate. So you truncate both of them to minute and then do a comparison and say is equal to, or whatever you wanted to do from there.
I was thinking because most of the time, by default, you have nanos as well.
Yep.
Yeah, so you've got to restrict the nanos and then.
True.
Yeah.
Yep. So the next one is local date time. So this contains a date and a time in it. So again, you can construct it with a now, or you can construct it with a date, or year, month, day, hour, minutes, and hour, minute, seconds, depending on what sort of granular thing you want. And then all of the methods that you previously used all come through into this. So plus days, minus hours are all available in this. You can truncate to and specify a level you want to truncate it to. You've got a with clause, again, so you can continue to manipulate your local date time objects and stuff with the with clause.
Sorry? Do you have any daylight saving time support? Because I don't have a time zone?
Yeah, yep, good question. And that's on the next slide.
Okay.
So if you bear with me, we'll get to that in a sec, Jackie. So we've got an instance. So this is, as we said, this is the closest equivalent to a Java util date. And this basically is an epoch timestamp and stuff. So you can instantiate it with a .now, and you've got the similar sort of functionality that you use with the others, with a is after, is before. So it's sort of similar to the other, to a local date time object, but it doesn't quite have all of the functionality that's available. This is really designed for getting a quick way to get a timestamp in the system. So a zoned date time now adds in a time zone, and this actually implements, all the time zones implement all of your, it's called a zone rules. So it actually implements zone rules, and you can go and create a zoned date time, and those zone rules will then turn around and give you the ability to take into account your daylight savings time and so on and so forth. obviously because, and it also makes it really easy to convert between different time zones as well. So you can actually just create a zone date time object, and you can just keep applying a different zone ID, and you can instantly see what at that point in time would look like in the US versus in Australia versus in New Zealand versus wherever, by simply just changing the zone ID of your zone date time. So this is based off the regional zone rules, which are a part of the Java software, or the Java JVM. So it's built in as a part of that. It's worth being aware that those zone rules do change for political reasons. They keep changing when daylight savings kicks in and kicks out again and stuff. And I've got some code I'll try and show you guys if we get to it, where you can actually read that and actually find out whether it is in DST or not. And you can also see what the zone rules are to see when it's going to kick in and out as well. But a zone date time object, again, you've got the similar sort of stuff, and it's consistent with what you did with a local date and a local time. So you've got plus days, minus hours, so on and so forth. You've got a toString, which again is in the ISO format, so it's a year, month, day. It indicates it's got a time zone, a year, month, seconds, and so on and so forth. Okay, so there's a pile of different calendars available. So the default is a Gregorian calendar, but you can actually change and use different calendars. So there is a Japanese calendar. Apparently there's an iTunes calendar. And there's a Thai Buddhist calendar, and many other calendars are available as well. But there are a few caveats. So I haven't actually used this myself, but everything I read sort of warned about using this, particularly this recommendation down the bottom, which is use the standard ISO calendar, and then just use your other calendars for presentation and convert it into your different format for presentation. It's sort of highly warned against trying to mix calendars in the core of your application where you're actually storing and managing and calculating your dates. If you start mixing up different calendars, it can cause a whole lot of problems, particularly some calendars. I think it's the Thai Buddhist calendar, but I think they've got like 13 months and stuff in some, so converting between those gets a bit messy. But it can be done. So the final section is amounts. So there's part of the new DateTime API also includes durations and periods. So amounts, talk about 6 years or so many seconds or a quantity of time. So in duration, you can instantiate one and say duration of hours or duration of minutes or whatever. And then you can multiply it, plus minutes, plus hours, and so on and so forth. And then you can actually use that with your local date time or your zoned date time with a plus, and you can actually add and manipulate those with durations. And same with a range. So a range, you can say create a period of 9 months or a period of so many days. And then you can create a period by actually comparing two different dates and get a period object back, and then you can manipulate a date using a plus or minus method on that as well. So that's sort of the summary, and if this works, ta-da, cool. So I created a little package here, and I can share this on the meetup page afterwards if you guys are interested. So there's a little example here of using a local date. So this is basically just what we had on the slide before. So you can actually create a date with a .now and present it down on the screen. Use a toString to get it in that ISO format. You can instantiate it using some literal values. You can then test it and see if A is after B. To compare those two dates. You can call it .getYear. You can test to see if it's a leap year. and you can then turn around and manipulate it using plus months, minus days. You can get with day of month and with they're both using with day of month. Well, anyway, so it'll set it to the first day of the month and then reset it again to the 10th day of the month. And then print that out. And this is where we get into these temporal adjusters. So you can actually specify it to the last day of the month, or you can say to the first in month, and you can say to the first Wednesday of the month. So if you want to find out when the next JVM meetup group is on, then you could use a temporal adjuster based on the date, find the next for the next time for the first Wednesday in the next month. There's also, I will add in another note, I haven't perfected it, but you can actually create your own custom temporal adjusters. So if you had your own events which were going to occur at some other odd interval, like your pay runs or something or whatever, then you can actually create your own adjusters and then just manipulate your dates using a custom temporal adjuster. So you can create one with, you know, on the next payday or on the next.
Where does the next method come from? Is it static on the order?
I think that was some of the references I was reading about creating custom ones, and they use next as their custom adjuster. So I tried creating one, but I didn't have time to perfect it. So if someone can perfect that, they can come back and share with us how it works. So how am I doing? Have I got 2 minutes?
Yeah.
Okay. So from there we move on to the time example. So this is again, this is the same stuff that was on the slide, but it's just in a class. So it's just different ways you can instantiate it. You've got your is after. This has got a get hour or whatever, which is relevant to time. And again, you've got your truncated to, and you can specify what you want to truncate it to. So you can use an enum to truncate it to seconds or minutes or hours or whatever you want. And then of course you can modify it or manipulate it using plus and minus. So an alternative to using a chrono unit and truncating it, you could just specify with nano as 0. Is another alternative. Will manipulate that object.
Tim, are they immutable?
Yes.
So everyone getting a new instance that reads
Correct.
hours once.
You are, yep. So all of the new DateTime API is immutable. So there's a couple other examples here, just working through all these. So we've got date, that's our DateTime one. So this is all pretty much the same. So we're instantiating it with a now. We're defining it, instantiating it with a specific period. We've got get year. We've also got get hour because this contains a date and a time component. And we can still manipulate it with plus days because it's got a time component. We can minus hours on it, and we can truncate it, and we can specify with a day of month or whatever else through there. And the next one was a zone info example, and someone had a question about this. So in this one, I'm setting a zone ID of Melbourne, and I can go and print out and show my zone that I've selected. I can then create a local DateTime.now, so that gives me my current date and time. Gives me my current date and time of the system, and then I can specify at a specific zone. So I can then see what my current time zone of my system is, and what that would look like if I was in Chicago. And I can then print that out to the screen, and that'll show me the American equivalent of my current date time object. Because I'm now specifying a time zone, it then returns a zone to date time because the basic local date time doesn't have a time zone attached to it. I can then instantiate, of course, using a full year, month, day, hour, minute, second, nano, and specify a time zone, which is this A object I constructed at the top there. I can continue to adjust it in the same way we adjusted all of the other objects. We can use a plus weeks, minus hours, plus days, and so on and so forth. And then down here I found it was interesting to be able to go and get the offset of the, which was my my American Chicago one, and so I can actually tell that it's plus 10 or minus 5 or whatever time zone it's in, and what the actual offset is for that. I was also able to turn around off A, which was my Australian Melbourne time zone. I was able to go and get the rules for it, and I was able to then go off and get the transitions, which is that start and end of daylight saving time. That returns me a list, and I was then able to go through and you can iterate through the list or whatever, and you can actually print out on the screen and say, you know, this starts and ends at this time, and the offset was, you know, plus 10 or plus 11, and then goes back to plus 10, and so on and so forth.
I've got a question.
Yeah.
Yeah, I always find annoying, you know, figuring out which string should I put inside the zone. I mean, to get the actual time zone, right? Isn't there any numeration to have that, or why there isn't? Or
There is an ISO standard, so there's actually these strings where I've got America, Chicago, or Melbourne, Australia. There is actually an international standard that actually defines all of those. I'm not sure. I'm not aware of a a numeric key that, you know, number 5 will always be Melbourne and number 10 will always be Chicago.
yeah, well, not a number, but an enumeration with the thing already.
Maybe
Like,
too many, or they change, or
well, if
something.
there, I mean, my point is, if there are too many, I don't see a problem with enumeration. If they change, they might need also, because if, like, somehow they have to have this string, like, inside the like, in the libraries to be able to get the time difference and the daily savings and everything. So I don't know.
They do. Yeah. So all of those strings are stored. As far as I'm aware, they are actually a preset standard. In theory, they shouldn't change. The dates or the transition periods will change and stuff for daylight savings and stuff, but unless they start creating new countries and stuff.
So that's why I was just saying that it would be good to have an enumeration with that, because I always find annoying. I don't know if it's a forward slash or a backslash or a dash, or it's starting in uppercase, in lowercase and stuff. So
Sure.
I don't know.
There we go. So I can just go and run this. So this programming dumps out, it shows me my select zone ID, dropped out the date time, which was set to America. It then resets it, gives me an Australian version of it, and then alters it, and shows me my transition. So it shows me my rules started, ended, and my offset was plus 10 and changed to plus 11. So you can get all of that information in the new DateTime API.
Following on from that, I'm wondering if what zone ID is. Maybe it's just a wrap around the string.
I think there's a bit more to it, but I haven't pulled it apart, so I don't know.
Might take a look at that later.
Definitely, yeah. Cool.
You can get a list of them, I think. So you can query for a list of all the available zone IDs.
Yes, you can. That's great. So in summary, we've got all these new classes. So we've got our local date time, we've got new amounts or duration period, and we've now got a lot more consistency around the methods that we can use as we work with the new classes there. So we've got .of, .with is consistent, plus and minus consistent across most of those as well. And our local, or our zone to date time also includes our offset and our zone rules as well. Any questions? Sure.
Is there a combination of duration and period if I want to know if some event is like in 8 days and 5 hours? Or do I have to calculate from the hours, the days?
So no, so you can. So if you had a duration that was 48 hours, I believe you can call a .get days, and they'll actually return you and tell you that that's 2 days or whatever. Cool. Thank you.